Alright guys, welcome to the Academic Lab with Lakeisha Mosley. Today this video is going to be about multiples and divisibility. So let's just jump into it. So multiples are basically where we have our multiplication rules, okay? So if we look at it says the multiples of 5. We're basically taking a number and we're multiplying it by things like, that number times 1, times 2, times 3. So this is very straightforward. Just know your multiplication facts. If you have not committed all of your multiplication facts to memory, then the biggest thing is you need to write them over and over and over again, at least 5 or 6 times through, like your 7s, your 8s, your 9s. And then before you know it, you will have all of your multiplication facts to memory. So make sure that you do that if you have not got back down all of your multiplication rules. Okay, so let's look at this first example. Multiples of 5. So in this case, we have, one set of 5. So 5 times 1 is 5. We have 2 sets of 5. So 5 plus 5 is 10, or 5 times 2 is 10. 3 sets of 5. So 5 plus 5 plus 5. So 5 times 3 is 15. 5 times 4. So 4 sets of 5. And then 5 times 5. So it's very straightforward. So let's do the first 6 problems real fast. Okay, so if we look at the numbers they asked us to do for the worksheet, it's basically saying to us, find the first 4 multiples of each number. So in this case, we want to do 2 times 1, of course, which is going to be 2. 2 times 2 is 4. 2 times 3 is 6. And then 2 times 4 is 8. Okay, so those are the first 4 multiples. For here, it would be 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And again, if you're having any problem, just keep adding 4 or adding that particular number until you get to your 4th multiple. All right, so we'll add 4 to this and we'll get 16. For number 3, okay, I'm going to move a little bit quicker. So we got 6, 12, 18, and then 24. For number 4, we have 8, 16, 24, and then we'll have 32. For this one, we have 9, 18, 27, and 36. And for the last one, for number 6, we've been doing this a long time, so we know to count by 10. So 10, 20, 30, and 40. All right, good deal. So those are the first 4 multiples of these particular numbers, and so we're done with multiples. All right, for divisibility. All right, guys, so now let's talk about divisibility rules. Okay, so divisibility rules on the sheet, you can print it out, but I'm going to just say them, and I'm also going to show the page pieces of it, but a lot of them are really, really easy, so I don't want you guys to freak out too much. All right, so here we go. So divisibility rule of 2, we all know that one, right? A number is divisible by 2 if its one digit ends in a 0, 2, 4, 6, or 8. So that number would be even, so therefore it's divisible by 2. So if we look at these 3 numbers, this one ends in a 5, so it's not divisible by 2. This one ends in an 8, so it's divisible by 2, and this one also is divisible by 2 because it ends in a 0. And that's that. All right, for the divisibility rule for 3, okay, let's do something real quick. For the divisibility rule of 3, and I did a little bit of the work, so it says a number is divisible by 3 if the sum of its digits is divisible by 3. So if you add up all the digits and you get a multiple of 3, or something that lives in the 3 family, then it also is divisible by 3. So as you can see, the first example was 54. So I did 5 plus 4. I got 9. So this is a multiple of 3. So therefore 54 is divisible by 3. The next number was 480. 480. So if I do 4 plus 8 plus 0, I get 12. This is also a multiple of 3. So therefore 480 is also divisible by 3. Okay, and the last one was 923. So for 923, I added 9 plus 2, which is 11. 11 plus 3 is 14. This is not divisible by 3. All right, and again, we don't care if the number is 10,726 or 8,424. We have to sum up all of the digits, and if we get a multiple of 3, the number is divisible by 3. Okay, so now we're not going to worry about the divisibility rule of 4, so let's go on to the next one. Divisibility rule of 5. We know this one just like we know the divisibility rule for 2. So it says a number is divisible by 5 if in the ones digit it ends in a 0 or a 5. So this number, 945, is divisible by 5. This one ends in a 0, so this one is also divisible by 5, but this one ended in an 8. It's even, so it's not divisible by 5. Okay, so now let's look at the divisibility rule of 6. So listen very carefully. This one's a little tricky. Okay, so here we go. For the rule of 6, so I'm going to call it the rule of 6. Here's what it says. A number, okay, a number is divisible by 6 if it is divisible by 2 and, I want to stress the and, 3. So if a number is divisible by 2 and 3, then that number is also divisible by 6. So let's look at the example. So I have 945. So the first thing I'm going to do is this number even? Well, it's not even. It doesn't end in a 0, 2, 4, 6, or an 8. So guess what? It doesn't satisfy the rule of being even or divisible by 2. So just off the bat, this number is not divisible by 6 because it's not even. Next one. Let's look at 3,488. Okay, so once again, it ends in an 8 in the ones digit, so that means it's even and divisible by 2. So that's good. But now I want to sum these digits up to see if it's divisible by 3. So we're going to add 3 plus 4, which is 7. 7 plus 8, which is 15. 15 plus 8 should be 24. Okay, so let's look at this one more time. Did I do my math right? 15, 16, 17, 18, 19, 20, 21, 22. Oh, no, it's 23. I thought so. Okay, so no. This is not a multiple of 3. Okay, this is not a multiple of 3. So therefore, this number is not divisible by 3. It is even. It is divisible by 2. But however, it's not divisible by 3. So this number also, it's not divisible by 6. It's only divisible by 2. Okay, let's keep going. The last one is 4,200. So in this case, it ends in a 0. It's divisible by 2. And if I add 4 plus 2 plus 0 plus 0, when I sum those together, I get 6. Okay, I'll put it equal 6. So as you can see, it's even, divisible by 2. The sum of the digits equal to 6. This is divisible by 3. So this number is divisible by 6. Okay, it's divisible by 2, 3, and 6. Okay, so I hope that makes sense for the divisibility rule. So if it's divisible by 2 and 3, then it's divisible by 6. All right, so let's look at 9, the rule of 9. So the rule of 9, divisibility rule of 9, is straightforward because guess what? It's just like the divisibility rule of 3. It says a number is divisible by 9 if the sum of its digits is divisible by 9. So let's do this one more time. 945. We're going to add these three numbers up. 9 plus 4 plus 5. Okay, so I know that 5 plus 4 is 9, right? 9 plus another 9 is 18. So the sum of these digits is 18, and yes, 18 is a multiple of 9. So this is also divisible by 9, so this is divisible by 9. So if the sum of the digits come together and you get something divisible by 9, that number is also divisible by 9. So now let's check 3,488, which we had a little bit of a blunder, or I did earlier, but we're going to do it again. So we're adding up the 4 digits, okay? And I'll just do kind of by grouping. So 8 plus 8 is 16, 16 plus 4 is 20, 20 plus 3, just to double check, this was 23. 23 is a prime number, and so therefore it's not divisible by 9, and it doesn't live in the 9 family, right? So this number is not divisible by 9, okay? And then on the example for the worksheet, it had 3,200. So this one's a little different than the one for the rule of 6. It's 3,200. So let's add this one up. So we do 3 plus 2 plus 0 plus 0. And as you can see, if we add this together, we get 5. And 5 is not a multiple of 9. This is not divisible by 9. So this is also not divisible by 9. Okay? Pretty easy. The next one I'm going to do on the worksheet, because I had a lot of writing for the other ones. All right, very easy. A number is divisible by 10 if its one digit ends in a 0. So this is not divisible by 10. That one's not divisible by 10, but this one is. All right, so we walked through the examples. So now let's look at the ones at the bottom to do a little bit more practice, okay? And I'm going to do these on a sheet of paper. All right, so the question says, determine if each number is divisible by 2, 3, 5, 6, 9, or 10. Okay, I'm going to zoom in. All right, so if we look at 34, so it ends in a 4, so it's even, it's divisible by 2. Okay, so let me just put this one on paper. I'm going to move this real quick. Okay. So if I have 34, we know that it is divisible by 2. So off to the side, I'm going to say, okay, 2 works, comma. Now let's check the one for divisibility rule of 3. So it says sum the digits up. 3 plus 4 is 7. This is not divisible by 3, so 3 doesn't work. We're not worried about 4. The divisibility rule of 5 says if a number in the ones digit ends in 0 and 5, then this number is divisible by 5. So because it ends in a 4, it's not divisible by 5. For the 6 divisibility rule, it says if I am divisible by 2 and 3, then I'm also divisible by 6. So again, as you can see, 3 is not here because, again, we summed them up. This is not a multiple of 3. So because it does not satisfy the 2 and 3, this is not divisible by 6. Divisibility rule of 9 says, again, if you sum the digits up and get a multiple of 9, or that number is divisible by 9, then it's divisible by 9. And so, of course, it's not in this case, so 9 doesn't work. And this does not end in a 0, so it's not divisible by 10. So the only person, okay, the only person that is divisible into this one is 2. All right, let's go to the next one. For the next one, number 2, this was number 1, number 2. For 210, it ends in a 0, so therefore it's divisible by 2. If we sum the digits up, right, so if I do 2 plus 1 plus 0, I get 3, and there you go. This is also divisible by 3. So 3 is divisible into 210. It ends in a 0, so this number is divisible by 5. And then the divisibility rule says if the number is divisible by 2 and 3, then this number is also divisible by 6. So we're going to put 6 on here because 2 and 3 is there. Divisibility rule of 9 says if I sum up my numbers and get something divisible by 9, then I'm divisible by 9. But nope, that doesn't work. And then it ends in a 0, so it is divisible by 10. So as you can see, there are multiple numbers that divide into 210. All right, third one, I'm going to go a little bit quicker. So now we're checking 280. It ends in a 0, so it is divisible by 2. If I sum up 2 plus 8 plus 0, I get 10. So as you can see, this is not going to be something divisible by 3, so 3 doesn't work. It ends in a 0, so it's divisible by 5. As you can see, 2 and 3 is not on here, so this is not divisible by 6. For the divisibility rule of 9, I added the 3 digits together and got 10, so this is not divisible by 9. And the last one is it ends in a 0, so this is divisible by 10. So that's the answer for number 3. So just to go back over it, number 1, the answer is divisible only by 2. For number 2, it's divisible by 2, 3, 5, 6, and 8. And the last one, it's divisible by 2, 5, and 10. So 3 more to go. All right, let's look at number 4. 4,386. It ends in a 6, so it is divisible by 2. I'm going to sum together 4 plus 3 plus 8 plus 6. So in this case, we have 4 plus 3 is 7. 7 plus 8 is 15. 15 plus 6 is going to be 21. So this equals 21. Check my math one more time. This is 14, 15, 16, 17, 18, 19, 20, 21. I use dots. That's how I kind of count. All right, so 21. Yes, this is divisible by 3. For the divisibility rule of 5, it doesn't end in a 5 or a 0, not divisible by 5. I have 2 and 3, so this is divisible by 6. And then the divisibility rule of 9 says that if I sum my digits up and I get something divisible by 9, then I'm also divisible by 9. So is that the case? Well, we know 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27. So this is not divisible by 9. It doesn't end in a 0, so it's not divisible by 10. So then that's the end of it right there. It's only divisible by 2, 3, and 6. Number 5. I have the example 1,473. So it doesn't end in a 2, 4, 6, 8, or 0. This is not even, so it's not divisible by 2. We're going to sum up the digits. And I get 1 plus 4 is 5. 5 plus 7 is 12. And then 12 plus 3 is 15. This is divisible by 3. So it is divisible by 3. It doesn't end in a 5 or a 0, so this is not divisible by 5. For the rule of 6, I don't see a 2 and a 3, so it's not divisible by 6. I summed it up and got 15, so this is not divisible by 9, and it doesn't end in a 0. So 3 is the only one that goes into 1,473. And for the very last one, number 6, this one was 56,484. Okay, I'm gonna put an arrow, sorry, be consistent. Oops. Okay, so it is even, it ends in a 4, so it's divisible by 2. Now I'm going to sum together 5 plus 6 plus 4 plus 8 plus 4. Be careful with your math. So this is 11. 11 plus 4 is 15. 15 plus 8, sorry, is going to be 23. 23 plus 4 is going to be 27. And so as you can see, this is divisible by 3 because 9 times 3 is 27. So 3 goes, and that works. It does not end in a 5 or a 0, so it's not divisible by 5. I see 2 and 3 are divisible into this number, so 6 works. And then for number 9, like I said, 9 times 3 is 27, so 9 is also going to work, and it doesn't end in a 0. So the answer for this one is 2, 3, 6, and 9. So that concludes divisibility. Just going over them one more time. Number 1 was 2. 34 is only divisible by 2. For number 2, 210, it's divisible by all 5 of these guys. So 2, 3, 5, 6, and 10. For 280, it's divisible by only 2, 5, and 10. For 4,386, it's divisible by 2, 3, and 6. For number 5, 1,473, it's only divisible by 3. And then the last one, 56,484, it's divisible by 2, 3, 6, and 9. All right, so I hope this makes sense. Make sure that you try the practice worksheet. I have some examples on there where you just put yes or no, but in the exam, I am going to kind of model it the same way. I'm going to ask you if it's divisible by multiple numbers, and then make sure you're able to calculate multiples. And that concludes the video. See you guys later.